Hey everybody, it's Mr. Dean here. We're going to talk about the taco cart problem. Here goes. We'll get right into it. So there's one guy down here. You're down here at point A, and you want to get across the sand over the taco cart. And in the sand, this is all the sand. In the sand, you only go 2 feet per second. On the road, which is up here, on the road, you go 5 feet per second. And they told us in the problem these measurements. They told us that this side was 562 approximately, and this was 325. So Pythagorean theorem tells us that this hypotenuse is 650 feet. Great. And what we're looking for, we're trying to minimize the trip. So to go from A to C to the taco cart takes quite a while. To go directly this way from here is obviously the shortest of the two, but there's actually a better way. Somewhere along this road here, there is a point right there, and we'll call that distance from there x. There's a distance there that minimizes the time along the sand and along the road so you can get to the taco cart before anybody else. So we're going to set up a little bit of math here. One thing we need to know is we need to know this distance. We need to know it. We're not going to be able to calculate it exactly quite yet. We're going to need to put it in terms of x. So just like I found 650 with the Pythagorean theorem for the whole entire triangle, I see that this area here is still a right triangle, and I'm going to use this x, and I'm going to use this number, and I'm going to get an equation for this dash line. All right. So Pythagorean theorem says that this side is 325.6 squared plus x squared. You take the square root of that, and you have what you need. So you have that distance. All right, now we got to set up an equation for the time it takes to walk. So these are all distances. We need time. So I was just kind of thinking to myself, I usually think, all right, well, rate is like a miles per hour thing, and I think rate is like distance divided by time. So switch around things, that means the time is equal to the distance divided by the rate. And we know the rates, we got them right here. And we know the distances, we have them right here. We have an expression for that distance. And we'll have an expression for this distance too. This distance up here will be the 562 minus that x. But we have the distance and we have the rate. We just need to find the time. And to minimize that time, we'll take the derivative of that equation and set it equal to 0, and we'll be home free. So here we go. So time in terms of x is going from A here, and we're going to head out to the taco cart. So follow along here. We're going along this route. So we got 325.6 squared plus x squared. And instead of square rooting, I bring it to the 1/2 power. Just it's easier to take the derivative when it's to the 1/2 power. And that is divided by, remember this distance, we're going to divide it by the rate along the sand, which is 2. And we're going to add that to this amount of time, which we had said was, it's the 562.6 minus x divided by 5. Divided by 5 because that's along the road. You're going a little faster. You're going 5 feet per second. All right, and we're going to get the derivative of this, and we're going to set it equal to 0 in just a moment. But that's so far as our time equation. We'll come back to that when we need to find out the final answer of how long it takes. So the derivative with respect to x is, we'll take the 1/2 exponent. We're going to need a little chain rule here. 1/2, put it out in front. 1/2 times the 1/2 is 1/4. Then we rewrite, and I'm going to leave this as just squared for now. Rewrite that middle, and then don't forget you have subtracted 1 whole from this 1/2, so you're going to get a negative 1/2. All right? And then over here, before I even write plus, on this side, this number divided by 5, this 560 number divided by 5 is a constant. The derivative of that is going to be 0. So really what I'm thinking about is the derivative of just negative, really it's negative 1/5 x. And the derivative of that is just negative 1/5. All right? It's interesting that that part really doesn't play much of a role in the final answer. So we're going to set this derivative equal to 0 because it's time that we want to minimize. So set the whole thing equal to 0. And this is a plenty difficult problem that I would go to a calculator or do it on my computer, do it on Desmos or something like that, and find out when that's equal to 0, when that whole thing, you're not going to factor that or any kind of thing, that's just too difficult. But it turns out on the calculator that I got x equals 141.7 feet. And when I plugged in, so that is the answer to how far it is from, I'm labeled at point C, how far it is from point C. It's 141.7 that far. And to find out how much time it takes, I'm going to use this time equation. I'm going to plug in 141.7 into here and into here, and that's going to tell me how much time it takes. So trust me when I say I did it out, and I got, in seconds, I got 261.7 seconds, but I turned it into minutes and seconds, 4 minutes and 22 seconds. All right, I hope that helps. There's the whole problem. We're good.